All right, so we've seen the first type of geometrical shape, the linear arrangement. I'm going to go a little faster with the next couple. Certainly there'll be an opportunity for me to review it in a little bit, but the next one is a trigonal planar. And I'm guessing that you can see already this trig, it's going to have 3 somewhere, and it's going to be planar, it's going to be flat, it's going to be not in 3 dimensions. So let's take a look at an example. An example is boron with chlorine, so boron trichloride. And so boron has 3 available electrons, 3 dots around its structure. Excuse me. And chlorine has those 7 again. Okay, so there's the 7 around 1 chlorine, 2 chlorines, and 3 chlorines. Okay, now, as we see right here, we've got 3 available, 1, 2, 3 around the boron, and then 1 available on each of those chlorines. It makes total sense, I hope, that we're going to have a bonding, a bonding, a bond. James Bond. Love James Bond. Anyhow, so 3 bonds, 3 different bonds. So when you clean this up, boron with 1, 2, 3. I won't put the chlorines just yet. You see the bonding. Now, I think what you also are hoping to, or I'm hoping that you can see right here, is that we have a 90-degree angle here, a 90 here, and a 180. Well, it's not going to stay like this because obviously these 90-degree angled electrons, they're not as far apart as they want to be. Valence shell electron pair repulsion, they want to get as far apart from each other as possible. So the way that they're going to do that is get in this pyramid, or excuse me, this trigonal shape where, of course, the bond angle becomes 120 degrees. So I should really put my chlorines on, and again, you want to keep those unshared pairs, those extra dots on the chlorine, and here we are. So this is the trigonal planar shape. Notice the bond angle of 120. These happen when you have a central atom, there's your boron, central atom that has 3 different atoms coming off. And I consider, even though they're all chlorines, I still consider them 3 different because one chlorine is different from another. It's all chlorine, but they're still different atoms. So 3 coming off of a central and a nice planar flat arrangement. Okay? The next shape, and again, I think you're going to see here real quick as I just kind of go through that I put my bond angle again of 120 degrees. The next type is called a tetrahedral, and I actually have a little picture already, but carbon tetrahydride, carbon with 4 hydrogens, is an example of this. Carbon, 1, 2, 3, 4, and hydrogen, there are 4 of them, each with 1. So again, 4 hydrogens, each with 1. I hope that we see we're going to have a bond, 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 and another bond. So we've got these 4 bonds. Cleaning it up, boom, 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 boom. So we have carbon with 4 hydrogens around it. Now, this is not exactly how it's going to get. And the reason this is, if you look at it in terms of angles, you've got your 90 degree, and there's no other way for the arrangement to get more than 90 degrees, unless it gets into a 3rd dimension. So because you can get 3D, because of 3D, what's going to happen is these atoms will get a little further apart. Notice that these electrons can get further. This looks like a little bit larger than 90 degrees. You know, 90 would be about there. So it does look like more than 90 degrees. And the reason that is because notice it's not a planar or flat molecule. If I'm holding these 2 balls, so these 2 hydrogens, the ones that I'm touching, are in the same plane as the carbon, this hydrogen bond is coming out towards you. This one is coming away. So we're getting 3 dimensions, and since we're getting 3 dimensions, we can get further than 90 degrees. So how do we draw that? Well, the way that we're going to draw more than coming out or going behind is, here's our carbon, and if you recall, I have 2 hydrogens in the same plane. So 1 2. We just draw them with regular dashes. This one is coming out at you, and the way that we represent that is by drawing a triangular looking dash. So, it makes sense. Here's your carbon, and it's getting bigger, like it's growing towards you. Just like you see my little fist right here. Now my fist is right up in. It's obviously a lot larger. So that's why we have a triangular looking dash. This dash is coming away from us, or going into the third dimension behind us. And so the way we represent that is with a dash dash. So anytime you do a tetrahedral molecule, you must have, and again we would have hydrogens on this, okay, you must have 2 in the same plane, 2 in same plane, 1 coming out, 1 out towards you, and 1 behind. And again, that's just how we do it. So all tetrahedral shapes, 2 in the same plane, 1 coming out at you, 1 going behind. So you should always have that dash dash or that triangular looking dash. So that's the tetrahedral. I've got 2 more. I'll do that on the next slide.